My name's Danny Forster, and I've traveled the world investigating architecture. And right now I'm going to take you behind the scenes of one of the world's tallest skyscrapers. But it's not just a big building. This is one of the world's first ever carved towers.
After decades of living in fear of attack, Kuwait is boldly re-entering the world stage, building the tallest twisting structure on the planet. Spiraling up 1,350 feet tall, Al-Hamra will be taller than the Empire State Building.
Now there's no denying it. We're up.
With two gravity-defying walls flying out in opposite directions.
I'm going to want to kind of fall over that way.
Exactly.
And that's actually happening to this building.
Right.
Covered in over 2,000 tons of limestone, making it
one of the tallest stone-clad structures in the world.
And topping it all off, a 17-story restaurant that's one of the highest ever built.
Of all the times I've heard "Don't Look Down," this is the one that I'm really being serious about. I'm in Kuwait, a tiny Middle Eastern country with less than 1.5 million citizens.
Situated on the border of Saudi Arabia and Iraq, it's one of the smallest countries in the Middle East. It sits on the second largest oil fields in the world.
And it was in 1990 when scores of Iraqi tanks crossed the Kuwaiti border, seizing control of this country and taking possession of their oil fields. And after 8 months of occupation, the Iraqi army was expelled by U.S. forces, leaving the country deeply damaged and their oil fields burning in their wake.
Fearing another attack, the country halted development for 15 years. But now, after the fall of Saddam Hussein,
Kuwait is finally ready to begin a new chapter in their history. And to signal that to the world, they're about to build an enormous piece of architecture.
The Al-Hamra Tower. At 1,350 feet, it'll be the tallest building in Kuwait, a skyscraper like none other in the world, with two one-of-a-kind walls flaring out 150 feet in opposite directions, whose revolutionary curved glass facade makes a massive sweeping turn. And at the top, a 200-foot enormous open space that'll house a restaurant like none other.
So Abdulaziz, tell me about the decision to select this design for the tower.
We based the choice on putting Kuwait on the skyscrapers race and creating a new icon for Kuwait City. This will not only add to Kuwait, but it will add to the international community of skyscrapers. The Al-Hamra Tower will stand unique and special among all its peers in terms of skyscrapers.
To stand unique means engineering the previously impossible, namely the two flaring walls that define the highest twisting tower in the world.
So those two flare walls, as the building rises up, the east side comes in,
Right.
while the west side pushes out.
Absolutely.
And what does that do to the building?
Now that puts an extra weight on the part that is protruding out.
So it's if I were holding like a dumbbell,
Right.
and I pulled one arm in and put one arm out, I'm going to want to kind of fall over that way.
Exactly.
So what do you do?
Well, what we're doing right now is actually building in an opposite twist. So when we cast our concrete, we cast it with an opposite twist.
Because of its weight and gravitational forces, the concrete in a skyscraper compresses or creeps over time. In rectangular buildings, this happens vertically. Knowing this, engineers build a structure a few inches higher so it settles to the right height. At Al-Hamra, it creeps not only vertically, but its twisting shape also causes it to creep horizontally counterclockwise. To correct this, they're building each floor an extra fraction of an inch clockwise from where it'll end up. So when it settles, it'll be perfectly straight.
So you're actually building the building counter-cranked in the opposite direction.
Correct.
With the knowledge that concrete will creep over time and straighten itself out.
Absolutely.
Building the right shape isn't the only challenge. The entire skyscraper is built with concrete, almost 500,000 tons of it. And engineers need to deliver that concrete a quarter of a mile in the air.
Now what you'll notice is the concrete coming out is unexpected. unexpectedly watery, but that's actually okay. This concrete is really amazing. It's simultaneously incredibly strong, but also viscous enough to travel as far as it's going in a tube.
Using high-powered pumps, the extra-strength concrete can travel over 1,200 vertical feet in less than 15 minutes. Any longer than that, the concrete would cure and lose some of its strength before reaching the top.
So now that the concrete is finally in the hopper, we're going to take the elevator, meet the concrete up, and pour it into what will be the highest flare wall done thus far.
While the western flare wall terminates at the 68th floor, the eastern wall will climb to the peak of the building. Today, teams are extending this wall an additional 15 feet.
So now, I'm on top of the climbing formwork, headed to meet the concrete over here. Unlike most walls you've ever seen before, this one is angling towards me. And if you can imagine, it's this very wall, this flare wall, that's going to travel up all the way to crown the entire tower at over 1,300 feet in the air. And today, we're going to add another 15 feet to the height. That is the articulated arm that enables us to move concrete anywhere on the top of the tower. So at this point, it's coming down towards me. We're going to send it to the very perimeter edge of the building and start the pour. What we're trying to do now is keep the boom inside the perimeter of the walls. It's a kind of unruly device, and it's all the way boomed out from there. So every little inch he moves it, the thing pushes back. You can feel the concrete pushing this thing back and forth. And the issue is if it busts out, we'll be pouring concrete either inside the tower or worse yet over the edge. Here it comes. The pump is primed, the tube is connected, and we are now flowing. 6,000 PSI concrete is coming up over 1,200 feet in the air to fill this twisted flare wall. The notion that anyone is actually listening to anyone blows my mind. What is going on here? Is anyone listening to anyone right now? Well, are you understanding? Because he's yelling at you and you're yelling at him. It's an amazing manic process, right? It's all about speed. As the concrete gets pumped into the formwork, there's a man behind them vibrating the concrete, aerating it, getting the bubbles out. And all this has to get done before the next concrete truck arrives.
With the first truck empty, they have 2 more to go in order to complete this 15-foot section of the flare wall.
Hold it, hold it, hold it.
In 7 weeks, this amazing twisting wall will be finished.
The Al-Hamra Tower will be unlike any other skyscraper ever built. And its most unique feature is, without a doubt, these incredible twisting flared walls.
And enveloped in this shape is one of the most unique and challenging tops to a skyscraper. This crown will be a sweeping single floor that climbs 200 feet as it wraps around the building. Clad in floor-to-ceiling glass, it'll provide diners unobstructed views of the Persian Gulf and Kuwaiti skyline. But topping the building with this complex geometric space will take 6 months to complete.
What happens with the crown?
The structure on top of the 77th floor is completely different from anything that we have underneath. We're talking about 60 or 70 meters height, which is equivalent typically to a 17-story building, probably.
So you're putting a brand new, almost 17-story building on top of your existing office building.
Exactly.
And the crew has reached a major milestone in the process. Construction of the final floor, which will support this 17-story crown.
In order to build the final floor on what will be one of the tallest buildings in the world, you got to have some very tall scaffolding, which starts with pipes like these that connect to poles like these, which all together come to make